Howdy, everyone, and welcome to today's webinar, which is packed with a special guest and a hot topic in the AI ecosystem. I'm Kevin Blanco, Senior DevRel Advocate here at Appsmith, and it's fascinating how technology evolves. Just a few years ago, we were excited about chatbots, and now we're building AI systems that can actually understand and learn from your entire organization knowledge. Pretty incredible when you think about it, right? Now, speaking of incredible things, I'm seeing amazing people joining us from all over the world. Our community is global. And I want to have a special shout out to the Pinecone's community. I know some members are probably tuning in today. So drop a quick hello in the chat. I'd love to hear more. Where are you tuning in today? Because we're diving into something that I'm genuinely excited about, which is RAG pipelines and actually working with them in production. But very briefly, what is RAG and why it matters? Let me explain that with a scenario I'm seeing more and more today. Enterprises are sitting on gold mines of internal documentation, knowledge bases, and proprietary data, APIs, products, and beyond. But when it comes to leveraging this data to AI, they are facing some serious challenges. The first one I see is time to market. It takes weeks to train a model by data engineering teams. The other one that is pretty important is security and compliance. The risk of exposing that data to that is private and is internal to existing AI models. The other problem is scattered data in multiple places, like products, legacy systems, and bringing them together. It's complex. And of course, the struggle of keeping AI responses accurate and up to date with that company knowledge. Fine tuning, let me tell you, is not an easy thing. So that is exactly why Retrieval-Augmented Generation, or RAG, has become crucial for enterprises because instead of hoping your AI hallucinates the right answer, RAG allows you to ground AI responses on your actual business data. And to talk more about this, I'm thrilled to be joined by two experts who are going to show you exactly how to make this happen using Appsmith and Pinecone. First, let me welcome Joseph Petty, our head of developer relations here at Appsmith, and our fearless magician when it comes to tuning complex workflows into elegant solutions. Hey, Joseph, how's it going, buddy?
Hey, thanks for the intro. Yeah, you give me too much credit, man.
Well, I mean, we have seen you in every live coding and every Friday workshop you did, building complex stuff. So I think you deserve it, man.
Appreciate
Um,
it. Yeah.
so I have my coffee here. I hope you also do, and everyone who's watching this, because let me introduce our special guest. And I'm especially excited to welcome Bear Douglas from Pinecone's developer relations team, because Bear brings an incredible expertise in vector databases and has been helping developers to build production-ready rack systems that actually work in production and scale. Bear, welcome to the show.
Thank you so much. I'm excited to be here.
Awesome. Bear, where are you based off?
I'm in New York City, and
Ah,
I
nice.
I also have my coffee right over here. Ready for this chat.
That's
Cool.
good to know. That's good to know. We always need coffee to make sure we say the best thing we have to. So Joseph, I know you have prepared something to kick things off and get started with the conversation. I don't know, should I bring that into the table?
Yeah, give me just a second here to pull up the slide. So we're going to do a quick presentation just to talk about, what is RAG and kind of talk about some use cases before we get into the live app. I think there we go. We got it ready. Okay.
Yep.
So first we're going to talk about what is RAG and just define that before we get into the live app. And then we'll look at some common use cases and some different business solutions that you can build with the RAG pipeline. And then we'll look at how you can use those out-of-the-box RAG solutions like ChatGPT. They make it really easy to use RAG and AI chat, but they come with a few of their own problems and limitations. So next, we're going to look at how you can build a custom RAG pipeline to overcome those limitations with the easier out-of-the-box solutions. However, building your own RAG pipeline from scratch comes with its own set of challenges. So we'll talk about the traditional approach of building each component and setting up a RAG pipeline, and then compare that with Pinecone's integrated inference. So this is a different approach to building a RAG pipeline that simplifies all of those steps. And we'll be able to compare those and see how much easier and simpler it is to complete the RAG pipeline so that you can quickly iterate and test. And then lastly, we're going to look at how you can use Appsmith's UI as the UI layer for your LLM and for the RAG. So this gives you an interface to adjust those different parameters. You can make a couple changes to your chunking strategy, upload the documents and test it, and then you might start over and change something else and re-upload. And so you can quickly iterate on your RAG pipeline by using Pinecone's integrated inference and Appsmith as the UI. So first, what is RAG? Well, this is a technique that allows you to use prompting or generative AI and combining that with search and retrieval from a vector database, which allows you to produce more accurate and contextual aware responses. Now, this can help reduce hallucinations, and it also grounds the responses in facts. So if it doesn't know the answer, but you provide it with that extra context, even though the model wasn't trained on it, and it doesn't know on its own, by providing that extra data, you're going to get better results. Now, this doesn't alter the model itself. So fine-tuning actually updates the model, and it knows that information going forward for all prompts. With Retrieval-Augmented Generation, you're just giving it that extra context on the fly at inference time as it's needed. So it ends up being a lot cheaper and easier to set up than fine-tuning. There's less technical skills that are involved, less compute or overhead and cost. So it's definitely the first approach you should try before fine-tuning. But when you use those out-of-the-box solutions, they're kind of limited. So today we'll see how you can set up one from scratch.
Perfect.
All right, so we're going to talk about a couple of use cases. And the most common one is just a chat with a PDF. Most people have seen this type of a RAG solution where you can upload a document and then ask some questions about it. Another common one is extracting structured data. So like pulling information from an invoice, the total and the individual line items. So that's not so much chatting with the document, but getting exact data points from it. And then another use case is analyzing longer documents like a legal document, a contract, and being able to ask it specific questions. So if you have a contract that's 100 pages or more, and you're just trying to find out if this one thing is allowed or prohibited, it can be a lot quicker and easier to do with RAG. And then lastly here is searching through technical documents and either drafting a response to a support ticket or maybe even fully replying for that tier 1, that first response. You could use this to search through all of your documentation, get that response and send it off, or just draft it for a human to review it before they send it.
So very briefly, Joseph, I wanted just to stop you there before moving to the next slide, because you can upload PDFs to these particular tools like ChatGPT or Cloudera or any of those tools like Gemini, but it's going to live in my one-on-one conversation with that particular that particular tool. It's not going to be broadly accessible to the company, and it's also a bit hard to keep updating that thread with the ChatGPT or whatever, because I need to re-upload things, and if I need more data to be accessible to that context. So in this particular case, what we're seeing is empowering existing LLMs to ground them on existing data that you can easily re-upload and have more context to this particular LLM. So it's like superpowers for LLM. Is that what I'm getting right there?
Yeah, and what's also useful about building a data pipeline is that you're not bound to static data. When you upload a PDF to chat with ChatGPT, one, it assumes that you know that the information that you want to append to your query lives in that PDF and doesn't live in multiple different data sources around your organization. And it also assumes that that data is static. You might be trying to draw on information that is coming from live docs that are being edited in your docs editor. You might want to pull something from Notion and something else that is from a Slack conversation. And those aren't going to be a matter of static PDFs. So what building a proper pipeline enables you to do is stay on top of that information in a more real-time fashion.
Yeah, exactly. Which is what I was saying at the beginning. The fact that data is scattered in companies across multiple systems that we can even think of, like even legacy systems, and trying to bring all of that into a context for an LLM is super hard for enterprises. And I think that's the value proposition of this particular use case.
Yeah, it's definitely a lot more useful having a real RAG pipeline that your company controls and owns instead of the file being trapped in that one thread. because you can ask a follow-up question in that one thread, but then if you start a new thread and you want to reference that document, you're starting over. So, and that's actually leads into the next slide here. So when you're using those out-of-the-box solutions like ChatGPT, it is really easy to just upload a file and start chatting and send your prompt, but it's really limited as well. So like we just mentioned, you don't get the ability to reuse that file in the next thread. You'd have to re-upload it. But then you're also missing out on all the options that you could adjust in a full RAG pipeline that help improve the responses. So adjusting the chunk and overlap size, the type of model that you're choosing, there's just so many other options that are at your disposal when you custom build your own RAG pipeline. So yeah, this is easy, but some of the problems. So I just kind of went over part of this, but the ability to adjust the chunk and overlap size has a lot to do with the quality of the responses. If you're wanting a very specific answer, looking for like a 1 or 2 line answer to a question in a massive document, you'd want a smaller chunk size. But if you're trying to get a summary of a document and you need that context and overlap, right? So the type of document you're chunking determines the chunk and overlap size, the use case or the type of response that you want, and also cost. You can try to reduce the overlap for storage. There's just so many things that you don't get the option to do here. And like we mentioned, it does not store the document for future prompts. You'd have to re-upload it. Now, the data is going to be stored on OpenAI's servers, regardless if you completely host your vector store and your RAG pipeline, or if you just upload it there directly. But one advantage is that you're not uploading everything. You can own the RAG pipeline and host that in Pinecone, and then choose which documents you're using for retrieval. So it's in that sense, you're getting more control and oversight of how your data is used. And then this last point, I just noticed recently, when you're trying to use RAG or web search with a certain model, there's always this lag. So the newest model doesn't have support for file attachments and sometimes web search. And then that'll get added and they introduce a new model. And now you can use the O3 High Mini or whatever the newest OpenAI model is, but it doesn't have some of these newer features. So if you want to be able to use the latest model and have RAG, this is a time when it's worth building your own RAG pipeline, because you own the vector store, you can do your own retrieval, and then pass those documents onto that newer model that wouldn't have the RAG built in. So lots of limitations with that out-of-the-box approach, and that's where building your own custom RAG pipeline comes in. Now, there's a lot to this. There's several steps involved. So we're going to talk through after you've chunked the document and now you're ready to start using APIs to upload everything. We're going to kind of skip past chunking and just focus on the pipeline itself. And so the first step is that you create some embeddings from those chunks. And this will be a single API where you take a chunk of a document, you send off that text string, and it'll return a vector. It's an array of numbers. Now you get that back and you still have to store it somewhere. And this tends to be a second API. And a lot of times it's a totally different system. When pretty much all of these technologies and services came out, there was dedicated ones that just did the embedding with one API, and then it would be a different company and a different API to store it. A lot of companies only had a vector store, but you had to go embed it somewhere else first, right? And so here you've got 2 APIs and 2 different services that you're integrating with. And then you want to query it. So you've got your documents embedded and you want to perform some retrieval. So you've got a prompt and you're trying to find what documents match that. Well, that's going to be another API and you have to embed that query. So you take your text prompt, your question that you're asking, and that gets turned into an embedding. And then from there, you're going to perform retrieval so you can compare the embedding of the prompt with all of those document chunks that have been embedded. So we're at 4 APIs and we finally have some matching documents. But before you send that off to the LLM as an actual prompt, chances are you're going to want to do re-ranking and maybe metadata filtering or a hybrid search. I left that one out, but we're already at 5 APIs here. It could be another one for filtering as well, for hybrid search. So finally, you can send a sixth API call to take those chunks and have them re-ranked, take the top K results, however many you want to match, and then provide those to the LLM as the extra context. So building your own RAG pipeline from scratch, the traditional way, using each individual component like that, it's complex. There's 6 or more APIs involved. And it requires extensive domain knowledge, not just about APIs, but about AI in general, right? You have to know how to chain all of those APIs together and take an ID from this one and create an embedding, or to take that ID of the document. There's just a lot of juggling those responses back and forth and chaining it to the next one. And then you end up needing separate services for a lot of this. So it's not just multiple APIs, but multiple API keys, maybe multiple subscription fees. So when you use Pinecone's integrated inference, it reduces all of that to 2 APIs. There's a single API that allows you to embed the data, so to take the text and turn it into a vector embedding, and then it upserts that and saves it to the vector store in one API. So that handles the first 2 that we looked at in the longer 6-step approach there. And then the second API, this allows you to perform a query and turn that into an embedding so that it can be compared against the vector store. It does the search. You can also specify some options for re-ranking, hybrid search. All those other 4 APIs at the end there have been reduced to another single API. And so you're able to adjust and retest your entire RAG pipeline in minutes. Instead of uploading some documents and going through all those steps, and now you want to change a few parameters, it would be 6 different APIs that you're changing the body or the URL parameters. Here it's only 2. So it makes it really quick and easy to iterate.
That's pretty cool. And I just want to stop you right there, Joseph, for something that I believe is very important. I want to advocate for everyone who's joining here that maybe don't understand all of the concepts we have explained, because the truth is we have set chunking, embeddings, vectors, RAG, fine-tuning, and all of these concepts. You hear them every day on LinkedIn and presentations and everywhere. And I feel that sometimes not everyone who speaks about these terms know exactly what they're talking about. And that's why we have a AI, LLMs, fine-tuning, whatever, 101 terms glossary in our community portal, that if you scan our QR code that you should be looking in your screen right now, you can just go there and understand, this is what they're actually talking about when they mean about vector search or embeddings or fine-tuning and all of these concepts. And so I just wanted to make that clear for everyone who might be a bit lost. But I know that after the demo and the example that we're going to be working with Appsmith and Pinecone, it's going to be more explicitly to understand what they are. But I just wanted to make sure that you have that glossary handy, because you might need it in the future. And for those experts who are also joining, let's keep it up.
Awesome. Thanks, Kevin. Yeah, that's honestly one of the biggest challenges with learning AI and learning all these different topics is there's so many new terms. Like if you're a developer and you already know full stack and you're just trying to learn, say, a new framework, learn React or Vue, there's some new concepts to learn, but you don't have 200 new terms to learn the way you do with AI. There's just so many new concepts. So I think that's, even if it's not all that complex, just to one sentence can have 10 words you don't know.
Yeah,
and it changed very quickly, right there.
Yeah.
It does. And it can also be confusing when you are overloading existing English words to mean something that doesn't quite square with your understanding of it. So we call our product Pinecone's integrated inference. In an AI, inference is just when you use an AI model to perform a task or make a conclusion about some data by feeding it in there. So you might wonder to yourself, what is being inferred if I'm using this product to create a semantic embedding of my content? But it's just the term that we use to describe that, even though it doesn't totally square with the English meaning. So our integrated inference product provides embedding, re-ranking, and these sort of task-oriented features that also rely on AI models.
Yeah, and inference is commonly used in AI just to refer to inference time at the time of the prompt being
Right.
processed, rather than at the time that a model was trained, or during the RAG pipeline. Inference is that final step when you're sending it out as a prompt and then it's being evaluated. So, all right. So yeah, like I said, Pinecone's integrated inference, it really simplifies this process. This reduces it down to just 2 APIs. So you're able to reduce that complexity, but you still maintain the oversight and control. You have way more options on adjusting your RAG pipeline. And so that's where Appsmith comes in. We're going to look at how we can build an interface to adjust all those parameters so that we can quickly, on the fly, upload a file, adjust the chunk and overlap size, the character splitting method, or the text splitter method, rather. Character is one of them. And then we can upload everything, ask a question and test it, and then start over. Change the chunk size, change the splitter type, and quickly iterate on your RAG pipeline. Because just building a RAG pipeline is one thing. To do all the steps and effectively retrieve a document and ask a question, okay, you've built a RAG pipeline, now what? Well, you have to measure its effectiveness. How accurate are the results? And then adjust something and test again. And so that entire process of iterating, it can be a lot with those 6 APIs and doing everything through code. This is giving you an interface to really view and see what you're changing and quickly iterate on the pipeline. So we're going to use Appsmith to adjust the character splitter. We're going to use character and recursive, 2 different text splitting methods. And I don't want to go too much into chunking in this webinar, but I do have a post on the community portal that talks about splitting text and performing chunking with JavaScript on the client side. This is something that's usually done with Python, either locally or on the server. But when you want to iterate and see the results and then make an adjustment, to me, it's a lot easier to do that visually. And so I looked at some of those Python tutorials and I'm like, how can we do this in JavaScript? And a lot of them do have a JavaScript equivalent. So that tutorial there with a link is going to show you how to use the LangChain.js for creating the chunking, and then Compromise.js is a natural language processing library that will allow you to do recursive text splitting. And that's where it's figuring out what's a sentence, what's a paragraph. It's a little more aware of the structure instead of just looking for spaces or periods.
Yep, we just got that QR code on the screen. Again, you can scan it and just go there and take a look how Joseph built it.
Cool, thanks, Kevin. So this app, I'm going to show you the live app here in just a minute, but I just wanted to walk through kind of some of the features and what we'll be doing. So this will allow the user to upload a file from their device. Now, if you're looking for a way to set up a RAG pipeline where those documents are coming from your users, right? This is going to give you that web interface that they can just easily open in the browser, upload a file, and then send it to your vector store without giving them direct access to your vector store, right? We don't want to give them the direct credentials to Pinecone and to have full access to the vector store. But this could give you the interface where you collect a file from a user and then send it off to that vector store. And it also gives you the ability to share this with different permissions to the team. So our granular access control can be used to detect what department somebody's in, what roles or groups, and then show or hide certain buttons or pages. So you have an app that's fully capable of editing any part of your RAG pipeline, but maybe you just want to expose certain functions to certain users. So Appsmith comes in great for that, using Pinecone as the backend. And from there, you can integrate with any API or database or any other LLM using Appsmith's data sources and our SAS connectors. So you've got a front end and a back end for your RAG pipeline. And then from there, pulling in data from any other service, from Salesforce or Zendesk, whatever your company is using. So that's what we're going to look at today. That's the end of the presentation here. And I'm going to jump into the live app now. And the example I'm going to use today, we're going to look at 3 different documents from our docs that all mention the word embed. Now, Bear, when I say embed, what do you think of?
I mean, I work at a vector database company, so I think about semantic embeddings and those representations of chunks of data.
Obviously, that would be the most common one. That's what's going to come to mind for you. And if you search our documents, you'll find OpenAI's embedding. We have an OpenAI SaaS connector. And so you'll find the same meaning there. But there's two others that show up in our docs. So if you search the Appsmith docs, you're going to find how to embed Appsmith in another web app. And so there's a whole set of documents there with multiple hits for the word embed. And then you can also embed an external website into an Appsmith app. So now this time Appsmith is the parent, and then you've got another website embedded inside your Appsmith app. And so we're going to take documents from those three topics, from OpenAI's embedding, from our SaaS connector that talks about embeddings, and then embedding Appsmith in another web app, or embedding a website inside Appsmith. And if you just did a traditional database and searched the word embed, you're going to find all three of them, and there's not really any higher results, right? They're all kind of equal because it's just, they contain that word. It's binary, you know, either does or it doesn't. But with semantic search, the vector database is going to give you a score about how close it matches that particular semantic meaning. So we can ask a question that contains the word embed, but does it contain it in the context of embedding it in a web app, or is it talking about OpenAI embeddings? So that's what we're going to do today. I've got those three documents, and I've set up this app to where I can upload a file or pull it from a URL and scrape the website as Markdown.
Sorry, Joseph, can you zoom in just a little bit?
Sure.
People can see it. Thank you.
So I'm going to just show the UI before we actually go through the steps. Here I can select a file, and I've already got one loaded. This is one page of our docs for embedding Appsmith into an existing application. And so I've got the markdown here that we're going to embed. Next, we can chunk the document. And for this example, I'm just using character and recursive splitting. Again, there's a ton more info about that in the link that we showed earlier, but we're going to skip past the details there and just focus on the RAG pipeline part, comparing a couple different chunk approaches. And so we can change the chunk and overlap size here and have more or less overlap, but I'm starting with 800 for the chunk size and 400. Let me refresh and get back to the defaults there. I'm using the same defaults that OpenAI uses when you use their assistants. So ChatGPT doesn't let you change the chunk and overlap size, but an OpenAI assistant does, and the defaults are 800 for the chunk size and 400 for the overlap. So that's just my starting point. You can also adjust the separator and whether or not you want to keep that separator in there or not. So I'm going to use space and not include the separator. And then embedding. So once it's been turned into chunks, then we wrap each one of those chunks. It gets an ID. Zoom in here a little more. There's an ID, the chunk, and then some metadata. And this can be whatever you want to include. I'm including the test that I'm doing, which is different chunking methods. And so the category of this one I'm saying is character. And then when we do the recursive splitting, it'll have that value. And so we can upload these chunks, have two totally different sets of the same documents, but chunked differently, and then ask questions against each set and compare the results. So from there, we'll do retrieval, get back the documents, and see how they match, what the score is. And lastly, be able to actually upload it and see how the LLM responds based on the documents that were retrieved. So that's kind of the flow. I'm going to go and pick the first document. So I have one in there loaded up, but I'm going to start with this OpenAI one here. I'm uploading the file. It's already marked down. But if you're working with documents that are HTML, there's plenty of services and libraries out there that'll convert it. It's way more efficient to turn it into Markdown first and get rid of all that code. So I've got a file loaded up. We go to the chunking here, and I'm going to use character splitter, 800 and 400, the same defaults. And you can see that results in 24 chunks. So the chunk size is a max number of characters. It's 800, and this chunk ended up being 745. You can see this one got exactly 800, so there must have been a space there as the 801st character, I guess. And so it's going to split it to keep it within that chunk size, that limit for your particular RAG pipeline. And then from here, we can upload these to Pinecone. So actually, I want to jump over and show Pinecone real quick. Here's their the dashboard, and I'm inside the database section here on the one index that I've created. So I have an index that is using 1024 dimensions and the multilingual E5 large embedding model. You'll want to look at what embedding model you want to use, and then set the dimensions and set up your index to match. So you can see there are no records in this right now. I've set up the index and created an API key, and I'm ready to upload some documents to it. So here are the array of chunks, and it's text right now. It's not a vector, but this is that first step of Pinecone's API that simplifies the RAG pipeline. It's going to turn it into a numerical vector embedding and store it in the vector store in one API, where it's usually two for most of them. So embed the doc. You can see I got a 201 success response there. And if we come back here and refresh, and this is an async operation, so it might not be there the first time, depending on how many chunks you're uploading.
Bear, how does it feel to see the Pinecone platform being used by an external person?
Oh, I mean, of course, it's very exciting every time.
Every time I use it, I learn something new. I just found a bunch of new models that I can mess around with that you guys have added recently. So I've got more projects in mind as soon as this one's done.
Love to hear it.
So you can see that it just uploaded 24 records. So the individual chunks that were created back there. And I could do some retrieval on it right now, but it's just that one topic, that one document. So we're going back to the first step here. I'm going to clear out this file, grabbing the second document. This one is about embedding an iframe in Appsmith that has a website. So Appsmith is the parent, and then there's a website inside there. So I'm not changing anything on the chunks here. I want to have all three documents stored and chunked the same way, so that we're comparing apples to apples. So we will upload this section, and then back to the first one. I'm going to upload the third document, and then we'll ask a question. And so we should have about 100 or so chunks altogether. Again, it's async, so it might still be processing the last couple. See how many we have here. 81. I just want to make sure all three of them are done. Okay. So now that all the documents are uploaded, I'm going to the retrieval section here. We're not prompting the LLM yet. We're just going to take the same prompt that we're going to use and then use that to see what documents match. So I'm going to ask it how to embed Appsmith in a web app. And you can tell it how many results you want. I'm just going to take the top 3 results. So you can see that it has returned 3 different chunks that all came from the document that's about embedding Appsmith into an existing application. So another web app. I didn't use the word existing application. It understood the semantic meaning and the type of use case here for the word embed. So if you look at the scores, we have one that's 919, 0.907, 904. So off the bat, it has found 3 matches, and they're all the right documents. So that's pretty good, right? And the scores are all pretty high. They're all 0.9 something. But when you do this at scale with tons of documents, you're going to probably see this go down at first, and then you're trying to optimize your RAG pipeline and your chunking strategy and these different things. So we're starting out pretty good, but we're going to test it anyway, side by side with 2 different chunking methods. So I could ask a question with this set right now. We'll take the same query, pass those 3 chunks to OpenAI, and it's using those top 3 results that were found, so it can generate a better response. And I could ask this question without those documents, but now it's going to be grounded in real results right from our documentation. And so it works. It looks good. It's talking about using an iframe, and you would put the URL of your Appsmith app right here, and then just have that iframe tag in order to embed Appsmith in another web app. So it works, but we can probably make it better. We're going to do the entire RAG pipeline again and change the chunking method. And I'm going to go through a little quicker this time because we already saw how it works once. The one thing I'm changing is we're going to use a recursive splitter, but keep the same chunk and overlap size. So back to uploading a file, I'm going to do the first one, and this will create another set of chunks, another set of embeddings, but I'm using that category, the metadata field, and these will all say the category is recursive. So we can filter and only ask questions against this set of data the second time around. So I'm uploading the first 20 chunks here from round 2, and just quickly go through, do these next 2. All right, all 3 of them had a 201 response, and it looks like we've got 150 documents in here now. Let's make sure that's up to date. It's pretty quick. It's async, but it's almost instant for as many as you're uploading. So all of the documents have been uploaded now. So now we're going to start over and ask a question using the recursive data set. So we already asked this once using category of set to character splitter. This time we're asking the same question against a different data set. And you can see these numbers went up a little bit now. We've got 0.91. I think the first one, the first one's still below 0.91, but the other 2 have gone up. And, we can ask it different questions about different types of uses of the word embedding and then compare between those 2. So we already asked on embedding Appsmith in a web app. Let's ask how to create an embedding. All right, now these, let's see, the highest one is 0.846. If I change this to character, and it's just picking up off of this field, so I'm going to do that instead of typing it. Okay, it's gone down again. So in both cases, the character splitter was less accurate. However, it's still accurate to the point that it's finding the right document. In every case, it has matched the correct document, so it's at least the semantic search is accurate enough to find only the right documents. All 3 chunks have been the correct doc without hitting any completely bad matches, right? But the score of how confident it is about the match, we're seeing that it's more accurate when this is set to recursive. So that exact same question, it's still returning 3 documents from the same doc, but the score is a little higher. And you're going to see that effect. It'll have a lot more of an effect when you have tons of documents in there and a longer prompt, that could, maybe it doesn't know what words to match on. So if you have several sentences in there, right? Different words that it can match on. This might be 0.6, 0.7, and then you adjust your RAG pipeline to get up to 0.9. So this gives you a interface where you can iterate quickly. And Pinecone's integrated inference with only those 2 APIs gives you the back end where you can iterate on it quickly. So that was the main thing I wanted to kind of walk through today. I think we've got a little time if we want to look under the hood and see how some of this works. But yeah, Bear, what do you think? That's, I think, a really good way to approach this and be able to test the before and after.
Yeah, I think so. I think you showed it all very well. And I'm excited to see what people in your community are able to do with it.
All right. Well, I want to show, there's a couple technical things. I didn't want to spend the whole time building and show how all this was made, but there's just a couple points I want to go over. So when you're using Pinecone's API, the body type, it's not application JSON. It's application X-ND JSON or line delimited JSON. So it looks very similar to a JSON array, but you don't have the outer brackets or the commas to separate it. It's just a JSON object on a line, and then a new line, and then another one. So to use their API, most of it's pretty familiar, similar, but you'll want to change that content type and then make sure that the body matches as well. So the body, I have a function that returns the array of JSON objects, and then I'm just mapping each individual object to a string, so it stringifies that object, and then join all of them with a new line. And so that results in new line delimited JSON, which the reason that a lot of AI or LLM machine learning things use this format is with a regular JSON object, you have to parse the entire thing to read one value from it. And if it's this massive, thousands of lines of whatever, thousands of elements in that JSON array, it's very inefficient to keep reparsing that entire thing just to read one data point. But with JSON lines, each individual line is a valid JSON object. And so you can pull out just one line and parse it. So that's the main reason that this format is used. But you'll want to take your JSON, map each object to a stringified version of that, and then join them with a new line. So it's pretty easy, just map it and then join, and you'll have the right format. So that was one thing. And then if you check out their API docs, you'll see you have your host address here for the index. And let's see, we'll go to docs, reference, and we are using inference. And so a lot of these in the URL, it just says your host address. Maybe not the one I'm looking for. Indexes, vectors. Here we go. Yeah, right here where it shows host index and then the rest of the URL. So that's where you'll get that. If you copy this curl request, you can import that into Appsmith, or you can build each individual piece of the API separately. But you'll get this value from, back to the dashboard. Here we go, under your index. So you can copy that URL here. And between that and the JSON part there, just getting that format right, it was all really straightforward to set up. That's just the one or two things I wanted to point out in case anybody has a problem setting it up. So the rest of it was really easy. It's literally just two APIs for the entire RAG pipeline. And then I have that one API for OpenAI to send the results. And you can see in the body here, I'm just taking a stringified version of the hits. So that upsert query search, that's Pinecone's second API, where you're taking your query, turning it into an embedding, finding the matching documents, re-ranking, all those extra steps you can do in one API. So I'm just stringifying the results and then saying that here's the, answer the user's query using these documents. And this input over here, that's the front end where we just saw the query that I entered. So that's it. This was really easy to set up and then to iterate and to walk through, change the value. And I've done it several times now and tested different, chunk and overlap sizes. And it seems like if you had a massive data set to do, this would be a really good way to approach it with a smaller subset to test it. And, find an example like this where you're really testing that semantic meaning. We have 3 different meanings for the word embed. So look for cases like that where that you're going to have some bad matches in your data if you ask it, with a keyword. And I think it's just a really fast, effective way to iterate on your RAG pipeline and optimize it.
Yeah, that's definitely true. Bear, I understand that obviously Pinecone's more than just what Joseph showed us. I mean, this use case was amazing, but there are probably other tons of use cases and features of the platform. So I don't know if there's something you want to share, like more broadly about what Pinecone is for everyone who's joining from the Appsmith side who have probably never heard about it or maybe just saw what you could do. But I know there's probably potential for other stuff around Pinecone, right?
Sure, yeah. Any sort of semantic search use case that you might want for just building modern search into a web application, Pinecone is a very useful service for that. We do have people using us for classification and model fine-tuning, which is, again, something that's maybe a little bit deeper into the AI space than folks who are building web apps would necessarily have use for. But there's a lot of ways that you can use vector similarity to help you improve result quality on anything where you're trying to do high quality modern search.
Perfect. And if somebody wants to learn more about Pinecone or even join their community, where can they find things that maybe we can share with them?
Yeah, best place to start is just pinecone.io for our learning center. That's at pinecone.io/learn. Also, community.pinecone.io is where you'll find our forum, which is our discussion place, and it's where a lot of our employees hang out. So if you have questions about how to use Pinecone, or if you're running into any issues, you can find us there on the forum. And yeah, we try and get out to as many events as we can. So live in the Bay Area, New York, which is where we tend to concentrate. We have lots of folks who live there and run events, and also online doing webinars with partners and folks like you. So we'd love to hear from people in the Appsmith community if you have questions, or if there are things that could be clearer, or if you want to dive deeper on some of these topics around AI. Our Learning Center is a great place to start.
Perfect. Well, thank you so much, Bear. And before we wrap up, I really want to thank everyone who joined us today. Thank you for being a fantastic community. The Appsmith community is so global, it's so broad, and it's amazing. Thank you, everyone who joined us today. But a special thanks to Bear for sharing your experiences and everything you explained to us about grounding LLMs and this amazing platform, Pinecone. And Joseph, obviously, for always showcasing great use cases and simplifying the complexity of building something that could take days into what, like 20 minutes? If we take apart everything we said at the beginning, just a demo
Yeah.
was maybe 15 minutes. And it is a very potential use cases for enterprises. So thank
Awesome.
you.
Thanks, Kevin.
Yeah, thank you, Bear. Thank you, everyone. And don't forget to check the resources we shared as QR codes. Join us on the community portal where Joseph is always writing amazing articles. In our YouTube channel, where I'm trying to post as many videos as I can about AI and try to keep up with the hype and everything we're talking. We have the AI LLM 101 series of shorts that we're trying to push just to advocate for everyone who's new and understanding all of these concepts. But also we have more AI content in the pipeline that's just going to go more deeply into more serious and big use cases for enterprises. So with that said, if you enjoyed this session, make sure to follow both Appsmith and Pinecone on social media for more content like this, because we have more exciting sessions planned. In case you missed, a couple of weeks ago, Joseph put me into test and he burned my tongue with the spicy challenge. So in case you missed that and you want to see me crying, just go to our YouTube channel and check that video out. So with that said, thank you all again. Thank you, Bear, and have a great rest of the day, everyone.
All right. Thanks, everyone.
Much.
Take care.